So here's an example of thin layer chromatography, a very generic example. I think this one is green tea, where multiple samples from a particular lot were procured and they were tested against a standard. And then we compare them basically and make sure that they exhibit the same banding as you can see here with the standard. Obviously, if that matches, we're good to move it to the next level. The next level is testing it for the pathogens, the biological pathogens, which includes things like your coliform, salmonella, E. coli, and obviously yeast and mold, critical ones, amongst other things. The next test is obviously heavy metals. If there's an active in the material that is of interest, covalent root, so maybe you're testing the berberine in it, then we would perform a test on HPLC or a chromatography equipment. More sophisticated, allows us to look at ultraviolet and visible spectrum of that particular molecule's absorbance pattern, and also look at when it comes off of a very tightly packed column under high pressure, and we run it against standards as well. So pretty much everything run against standards. Now, if there was a mineral claim on something, so let's say we got something that is a mineral, maybe supplies zinc. Zinc gets popular often around, flu seasons, cold seasons, back to school. It's almost always critical. So material that has a certain content of zinc has to be validated. So we test it for zinc using an ICP OES. When we're able to identify there's the zinc, these are signature wavelengths for zinc, and then we're able to compare them against certified standards and quantify the amount of zinc that is there. So not only are we doing a qualitative check to say, is it zinc? We're also checking the quantity of zinc that is present in that material. We'll often get things like zinc lozenges, and we'd have to test the content of the zinc in that lozenge to make sure that the label claim is correct and accurate.